All right, so today we're in section 11.3 and we're taking a look at some data distributions and also how to choose the best measures of center and spread when examining some of our data. If you've watched the previous videos, gone through some of the previous Canvas quizzes, this should seem kind of familiar because in my excitement of getting to chapter 11, we talked about some of 11.3 and section 11.1. So let's go ahead and look at the textbook here as it describes symmetric and skewed distributions. So we already talked about this a little bit in a section 11.2 as well when we looked at our box and whisker plots. Here we're presented with three histograms, and they are skewed left, symmetric, and skewed right. So when we're deciding whether or not something is skewed left or right, you need to look for the tail. So the tail is pointed out on the left and right graphs, and it's basically the direction where there's a lot of data, but it's spread out over a wide area. So in our left skewed one, there's a lot of data points that are to the left of that highest value, that mode value. But none of the bars, not many of the bars, especially as you get further to the left, are especially large, but there's just a lot of them. So a lot of the data is ultimately over there. And that's what it means to have a left skew. It's also described as having most of the data are on the right. It depends on how exactly you define most to be, or not most, but where right is. I don't especially like that description. I think it's easier to just think of the mode of the data is on the opposite side of the tail. And if we look at the skewed right, you can see it's the same thing. The mode there is on the left side and the tail extends to the right. So the tail, it has this stair-step pattern that goes down, down, down and away, off and to the right. And we'll talk a little bit more about how this affects the distribution, or not the distribution, but the measures of center. And the symmetric one should be the one that's the easiest to point out because it looks like a bell curve. It looks approximately equal on both sides. Now, the only other thing I'd like to mention real fast is that the skewed left is sometimes called a negative skew, and the skew right is sometimes called a positive skew. Although I'm not sure it ever refers to it as such in this textbook. All right, so the next thing we're going to take a quick look at are measures of center, which we've already talked about a little bit, choosing the appropriate measures of center. So when a data distribution is symmetric, you generally want to use the mean and the standard deviation. So the mean is our measure of center, the standard deviation is our measure of spread. The one thing about having the symmetric data distribution is that the mean and the median are usually the same or very close to being the same. So they both will essentially describe the same piece of data, but we typically use the mean when describing symmetric distributions. So if you see the mean as being the measure of center, it probably is telling you that we're looking at a symmetric distribution like shown in this graph that looks like the bell curve there. Now, the standard deviation is a very, very convenient measure of center that we can use here because it actually tells us quite a bit about what the data looks like. And that's something that we'll see especially as we continue to go through this section of the chapter. The standard deviation actually provides you a significant amount of information when we have a symmetric distribution like this, because a symmetric distribution, sometimes called like a normal distribution related to the normal curve, which I don't think is covered here, but is a big statistics topic. The standard deviation will tell you a significant amount about where the data is located. Now, for this skewed data distribution, we're going to be using the median instead of the mean because the mean is significantly more influenced by the tail than the median is. So as you can see in the example shown here, the mean is pulled further towards the tail than the median is. But the median is a better representation of center because if you look, most of the data is around the median. Like the vast majority of the data is around the median. And then you have this long tail over here that causes the data set to be skewed in this direction. So the majority of the data is around the median right here in the middle, and the tail does not quite as do a good a job of representing the center of the data. It's the same thing with our left or our right skew on the other side. Most of the data is in these 3 bars right around the median. So this median does a good job of representing it, whereas the mean does not do quite as good of a job. In addition, the suggested method of representing the variation is the 5-number summary. And the 5-number summary is a pretty darn good one, because if you think about what those 5 numbers tell you, I mean, for one thing, it includes the median, so you have your measure of center. But the other 5 numbers can tell you what direction the data is skewed in and how significant the skew is, essentially, because the larger the difference between the quartiles, the more significant the skew is going to be. So that's why we would like to use the 5-number summary, because it can be very useful in describing this badly skewed data. All right, so I mentioned earlier describing the standard deviation and the bell-shaped and approximately symmetric distributions of data. And now we're taking a look at a graph that represents that. So if we look at this, we have a bell-shaped curve, and we have +1, +2, and -1, -2 standard deviations, or sigmas, away from our x-bar, the mean. And what's so nice about this is that in a symmetric data set, a normal distribution, which is what's being shown here. Let me include, even though this is something that's not really mentioned in the test book, this is a normal distribution. In this data here, if we have a symmetric normal distribution, in basically every data set, about 68% of the data is going to lie 1 standard deviation from the mean. 95% of it lies within 2 standard deviations of the mean. And if you want to go even further, even though this book doesn't, I'm going to go ahead and do it anyway. 99.7% of the data is within 3 standard deviations of the mean. So that tells you a tremendous amount of information about a data set if you know that it's going to be normally distributed. So if you're giving someone a standard deviation and the mean as the measures of center and the measures of spread, that already tells you a tremendous amount about what the data set looks like. So this is why it's so important to choose the correct measures of center, because you can provide very little information, or a very succinct amount of information that can tell someone so much about a data set. All right, so that covers a quick rundown of essentially all of the new learning for this section. And we're going to go ahead and look at a few applications before I send you off to do some assignments to review what we've learned in this chapter.